This video is an introduction to algebra. First of all, we're going to focus on a little bit of vocabulary. It's important that you learn this vocabulary well because it'll be getting used an awful lot over the course of the next couple of chapters. Here I've written x plus 2y plus 5. A statement like this in maths that has no equal sign is called an expression. Within this expression, we have a number of components. We have x, we have y, and we have some numbers as well. The x and the y, and in fact any letters that you come across in an expression, can be called variables. This is because, depending on the situation, the values of x and y might change or vary. Numbers like plus 2, which come directly in front of a variable, are called coefficients. Every variable has a coefficient. The coefficient of y here is 2. I don't have any visible coefficient in front of my x, but I could put one in if I liked. There's only one particular value that would actually be acceptable in this case. Do you have any idea what it might be? Well, if I look at this x, think about how many x's you can see. I can just see one of them. So if I liked, I could put the number 1 in front of this x. X and 1x are the same thing. So 1 is the coefficient of the x in this case. This 5 doesn't have a variable to go with it. Since it doesn't have a variable, I won't call it a coefficient. Instead, I call a number like this by itself a constant. Notice that when I talk about the 5 being the constant, I include its sign. It's the same for this 2, which is the coefficient. Plus 2 is the coefficient. The sign in front of a number goes with that number. Okay, let's move on from this expression for a moment. I'm going to mention equations because we will see them in the future, but I'm not going to dwell on them. 3x plus 2 equals 5 is an example of an equation. Think for a moment, why do you think this line up here, 1x plus 2y plus 5, is an expression, but this line, 3x plus 2 equals 5, is an equation? What's different about them? Well, the expression has no equal sign, and the equation has an equal sign. In fact, this is where the name equation comes from. Equa meaning equals. Take a moment to see, can you identify any variables, coefficients, and constants in this equation? Well, this time I only have one variable. It's the x. This 3 is the coefficient of x. This plus 2 and this 5 are both constants because they don't have any variables at the end of them. And just a little note, as I look through these expressions and equations, I see that some of the numbers have no sign. For example, this 1x has no sign. If there's no sign, I can think of it as being a positive. That's not so important now, but it's useful to know it for the future. Okay, so like I said, equations aren't going to be our focus for the moment. We're going to be focusing on expressions. And here's another expression. As I look through this expression, I can see that I've got some terms that have x and some terms that are just numbers or constants. A term is just an individual piece of information that makes up the expression. Here I've broken my expression up into its component terms. And I can see that some of these terms look a bit similar. So, for example, 2x and 3x, these both end in x. And as I said a moment ago, the 5 and the 2 are both constants. Terms that end in identical variables are called like terms. Constants count as like terms as well because they don't have any variable. I can add and subtract like terms as instructed by the expression. So for example, here I'm being told that I've got 2x plus 3x. These are two like terms, so I can put them together. To do this, I simply add or subtract, depending on the question, their coefficients. Here I'm adding because I'm told it's 2 plus 3. This gives me 5x. I can also put the constants plus 5 and plus 2 together, and I know that plus 5 plus 2 just makes plus 7. So essentially I've been able to tidy up this expression into a slightly shorter version, 5x plus 7. It's still the same information, but I've managed to simplify it. In this video, let's also have a look at a little bit of notation. Notation is just the way that we write things in maths. It might be a certain type of presentation, or it might be symbols that we use. I first of all want to look at the notation for multiplication. Now, if you're just multiplying numbers together, you might write down something like 2 times 3 using the multiplication symbol. Obviously, this gives us 6. But we don't really like to use the multiplication symbol in algebra for pretty obvious reasons. The multiplication symbol looks an awful lot like x, and since x gets used so much in algebra, the multiplication symbol can cause absolute terrible confusion. So if I wanted to write something like 4 times a, where this is the multiplication symbol, I don't want to use the symbol. Instead, I want to write it as just 4a. So we won't write it in this way. We'll write it this way instead. Notice that 4 is the coefficient of the variable a. So a coefficient is multiplying by the variable. Likewise, we don't tend to use the division symbol in algebra. With numbers, you might often see something like 12 divided by 4. Can you remember from any previous chapters any other way in which I might be able to represent this information? So I could write 12 divided by 4 as 12 over 4. And we prefer to use this way of representing division when we're dealing with algebra. So say, for example, if I had an algebraic expression, y divided by 3, I'd never see it written this way. Instead, I'd always see it written as y over 3. Make sure to review the content of this video well. You need to know your vocabulary. You need to know what I mean straight away when I say coefficient, variable, constant, term, expression, equation, like terms. And also review your notation. Make sure that you know how to write multiplication in algebra and how to represent division also. And in the next few videos, we'll be looking at how to apply a little bit of this multiplication and adding and subtracting terms also.